I've been talking a lot more about AI lately, and I want to finally put my money where my mouth is and show you something I have actually built with this. This is a real live web app that I just shipped like 2 or 3 days ago called Better Context. I've had the CLI for this live for a little while, but I just launched the new web app version of it, and I want to talk about how I built this, why I built this, the stack I'm using, and kind of just what building feels like in 2026 with AI tools, because this went from idea to in production in about 2.5 weeks. And it's not a complete toy app. Like, there is a fully functional chat UI in here. It is running an open code agent hosted on a Daytona sandbox in the cloud with full streaming. I'm using Convex for the database. I've got Clerk for auth. I've got Autumn set up for billings. I have actual Stripe set up in here. I've got a full MCP server working. Like, there's a lot of stuff in this project that I got working in a relatively short period of time, and I'm very happy with the outputs. Because yeah, things have changed and I want to talk about it. Before I get into the how, I want to talk about the why. And I think this quote from Simon Willison's blog does a really good job of showing what I'm talking about here, where he just said, I may have been too optimistic expecting a one-shot working program for a new language like this, because this is an article about a brand new programming language designed specifically for LLMs. So I ran a clone of the actual project, copied in my program, and had Claude Code take a look at the failing compiler output. And it worked. Claude happily grepped its way through the various examples and built me a working program. Here's the Claude Code transcript. You can see it reading relevant examples here. And here's the finished code plus its output. This is the super important piece right here, this /examples. This all started back in November of last year when I had a pretty bad crash out about effect because I was just getting really annoyed trying to figure out how to implement some pretty complex durable streaming implementations with effect. And as a result of this post, the creator of Effect, Michael, replied to it suggesting that I clone the Effect repo as a Git subtree within the project, give it to Claude, and use that as my documentation. At first, when I first saw that, I was like, what the hell? This is absurd. We have docs already. Why not just make the docs better? But I begrudgingly tried it. I wanted to be good faith here. And it was really, really good. I was able to actually figure out how to do the thing I was trying to do by letting the agent search through the raw implementations of Effect just as a normal coding agent. This was just open code loading up the Effect documentation using Haiku to search through it, and I got the exact information I was looking for. The 2 readable stream, the stream splitting stuff, it all just worked. And I was like, shit, maybe I should turn this into something more. So the first thing I did is I made a custom open code agent for it that was just like the docs agent that other agents could call. It was pretty good, but it was kind of hard to maintain and deal with. So I wanted to make it even better, which is why I then made the BTCA CLI. So this has been out for like a month or so. The way it works is you can do BTCA ask-r svelte-q, what are remote functions? How do I use them? And then what it's going to do here is it's going to clone the actual Svelte repo onto my computer, load that in as a collection, and then use open code to search through it, stream out the results. And now, oh fuck, it has the MCP in context. Fuck. Okay, I might have fucked up a little bit here. The MCP is actually loaded within this BTCA instance because my open code setup is completely fucked right now. So it's using the Better Context MCP in the cloud to actually do this. I'm curious if this ends up working. This is not, okay, so that did end up working, not exactly the way I intended it to. So you can see the actual output here. It got me a summary of here's what remote functions are, here are the 3 types, here's a quick example. I can actually see how these work, and that was incredibly useful for me. I was passing that into agents, and I really, really like this system. And then I kind of realized that I was chatting back and forth with it a lot, which is why I then made the TUI for it, which is this guy right here. So you can just tag in a repo. So I do @runed. How do I store state in the URL with runed? And I can then ask it this, and it's again going to use a local open code instance to search and do that. All of this is completely free and open source. It'll be linked down below. This was like a really cool project, but I was like, okay, I like this TUI setup. I like doing it this way, but I found myself really liking this TUI for kind of researching new technologies, but there's only so far you can go with a TUI. So what I ultimately did here is I turned it into a full web app. So this is a live chat app. It is fully live and in production right now. You can use it. You get 5 free messages, and then it is paid after that. I didn't really want to make this paid, but I kind of just had to because I have infrastructure costs for this. The sandboxes aren't free. Inference isn't free. But it does, like, you know, it's pretty cheap. And if there's other stuff you guys want to see added to this, just let me know. This is more just like a project that I wanted for me, but I figured I would publish it because I think it's really cool. And the same concepts work up here where I can do look into @opencode. So this is going to tag in the opencode resource, look into its MCP implementation, a bunch of stuff in here where I was just trying to figure out how MCP works within opencode. It did a bunch of tool calls to read through the code base and then gave me this really nice summary of it has this internal function call of convert MCP tool. And then it will turn those tools into active tools within the actual stream text call, which is from the AI SDK. So I thought that MCPs were being loaded in as some separate path within the agent, but apparently they're just normal tool calls, just like the read is, just like the write is. And that's really useful. I like being able to dive deep into code bases this way and use AI to search through them. And that's why I made this thing. But now I want to get into how I built this and what development feels like with AI in 2026, because it's different. But before we do that, we need to hear from today's sponsor. I want to talk about the weird ways my workflows have been changing. I made this post a few days ago. I've been working a lot on Better Context, a big open source project I've been running for a couple weeks now, and I've had a lot of issues come in. And instead of going through and manually fixing every single one of those issues, I wanted to see what would happen if I had my coding agent, OpenCode, pull down all the issues, triage them for me, give me a priority list of all of them, and then send each and every one of those up as an individual PR linked to the issue. I wanted to see if that was possible, and it ended up being very, very possible. But you'll notice in here, I use stacking for this. I have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 different changes staged up all at once, and the way this ended up being a very feasible amount of work to go through and review was because of today's sponsor, Greptile. They went through and reviewed every single one of these PRs. You can see on this one, for example, they gave it the nice 5 out of 5 confidence score, which for me was enough of a sanity check to just kind of move on to the next one and keep going through the list. But there were a couple that did actually have reviews on them. There were some important things that it caught. And what I ended up doing is actually using the Greptile MCP server within OpenCode to pull down the review and get it fixed. I just discovered this like 2 weeks ago, and it has become a pretty core part of my workflow at this point, where whenever I send up a PR, if there are a bunch of reviews in it, it's a huge pain in the ass to manually click the copy button on the review comment, paste it back into Cursor or OpenCode or whatever. With the MCP, all I have to do is just say use the Greptile MCP to check for reviews on this branch/PR, and then it will use the Greptile MCP tools to get all the context it needs, figure out what needs to be changed, make the changes, and send it back up. It's an incredible workflow that I highly recommend trying at davis7.link/Greptile. I think the best way to show off how a lot of the building has changed is to show you what it's like to actually implement a feature live within this video. So one thing that chat was talking about earlier was it would be cool if we had a Raycast extension for Better Context, where right now we have the web app, we have the TUI. What if I could just go into Raycast, do BTCA, and then ask a question in there and have that show up in Raycast? That could be pretty neat. I want to implement that. But in order to implement that, the agent needs to understand how to use Raycast. Out of the box, even Opus is going to struggle with some of the weirder commands you have to run in order to get it working. It's going to cause some problems. So the point of Better Context is to give it a source of truth that is rooted in reality, give it access to an agent which can search the actual examples and documentation for Raycast extensions to build this correctly. And the way you can add this to a project is you just make a btca.config.jsonc file. This is all documented on the website. Then I'm going to add a new resource in here, which is going to be of type git. It's going to be a name of Raycast. The URL is going to be this, the Raycast extensions. Branch is going to be main. Yep. And then the search path is going to be docs. Actually, I want examples. So one neat thing you can do is you can pass an array here. So we're going to do search paths. And then we're going to do docs and examples. So with all of that set up here, what I can now do is BTCA at Raycast. How do I set up a new Raycast extension? What commands do I need to run? So you can ask it how to do this. I'm going to let the agent actually do this and call the CLI for handling this. I'm just showing this right now to show you kind of how resources are loaded in, where we ask it this question. It's taking a second here because what it's doing is actually cloning it. You can see in this .btca directory, it's being cloned into this get ignored directory with resources, Raycast. It's bringing down docs and examples. How do I create a new Raycast project? Okay, there we go. Had some linking problems there. It's still, this is beta software. We're figuring this out as we go. But you can see what it's doing here is now it's searching through the actual Raycast implementation to show me how to actually do this. And I'm not like trying to plug this thing super hard. What I'm really trying to show you here is the most important thing you can do with these agents, especially when you're letting them run for longer periods of time and build more complex things, is you need to give them some grounding in reality. A lot of people are calling these like feedback loops, where stuff like statically typed languages have become really, really important, because if the LLM accidentally outputs the wrong function, or they make a variable snake cased instead of camel cased, it'll catch that immediately and tell it, hey, you fucked this up. So it'll fix that hallucination right off the bat. Tests are really good for this, and better context is just another way of doing this by letting it see how it actually needs to use these different technologies instead of guessing at it. Opus. So now that we've got this ready in here, and now that I have Raycast added as a resource in here, what I can do is start prepping this new feature. So I've been really liking using voice to text lately. I just find it to be a convenient way to work with these agents, especially when you need to give them a lot of details on how you want something implemented. So for this Raycast extension, I want you to go through and put together a plan for making a new Raycast extension for better context. Use /apps/web as a baseline example of what this kind of needs to be. It should be hitting the actual convex endpoints for spinning up the sandbox, streaming stuff down. The actual Raycast extension itself should basically just be one command. When you open up the extension, it should allow you to just type in some question, tag in some resource, and then hit send. And once it sends, it'll stream down the end results and show those in Raycast. I'm not fully certain if this is possible in Raycast. We're going to be doing a little bit of exploration here to try and figure out if this will actually work. Before you actually write any code, the first thing I want you to do is put together a detailed plan of how we could actually implement this, and then we'll go back and forth on that. Use BTCA heavily in this. Raycast is added as a resource here. Use that to explore how Raycast actually works, how we will create it. It should be a new app within the apps directory of this project. So that should be enough context for it to get going. We're going to leave that running in the background and talk about some other stuff. The first thing is the CLI. This is the BTCA CLI you can install off of NPM. This is built almost entirely with Bun. Bun is like the core dependency in here that makes it work. Bun allows you to create native executables for different platforms. That allows me to make a CLI super easily and distribute it super easily. I'm also using OpenTUI for the actual TUI view here. It's like earlier when I showed the TUI, that is written with OpenTUI plus Solid.js for the actual rendering. So it's basically a Solid.js app that is mounted within the terminal. It's really weird, but also really cool and works remarkably well. Then from there, it's honestly pretty simple. There's some extra stuff in here like Zod for parsing schemas and that kind of thing. We're using OpenCode very heavily, not just to build it, but we're using it under the hood. Because what better context actually is it's a wrapper around an OpenCode instance. You can run it locally and use your OpenCode credentials, because when I do BTCA ask whatever, that's going to spin up an OpenCode instance on my computer that has the actual Git repo loaded into context, so that it's like I'm opening an OpenCode session within that cloned Git repo, asking it that question, and then streaming that response back out in a different format to the end user in the TUI or in the CLI. It's a wrapper to make managing the resource life cycles way, way easier. And that's honestly like kind of it. The first version of this was written entirely in Effect. I am going to migrate it back over to Effect at some point in the future. The reason why I pulled it off of Effect initially is just because it was resulting in it overcomplicating a lot of things and making the code a lot harder to reason about, because the problem was the code base was changing way too rapidly for me to be able to really keep on top of things. And I just kind of found Effect to be a little too heavy for this, especially when I didn't know what I wanted it to be. So I kind of just let the agents build it in a pretty simple functional way where, yeah, it's using a lot of try catches. It's using a lot of like async stores and that kind of thing, which isn't ideal. We're going to fix it later, but for an MVP, it was fine. I just wanted these agents to be able to write the code very easily, because again, I didn't write an enormous amount of the code for this. I planned all of it. I thought about all of it. I architected all of it. I didn't write the majority of the code for this project. Then for the web app, this is where it gets really interesting and fun, because the actual front end for it is just a SvelteKit app. It is everything from this app interface to the actual like homepage and documentation and pricing and resources and all that stuff. All of it's written in SvelteKit. It is just one of the apps within the gigantic mono repo for this project. Then I'm using Convex for not just the database, but also for a lot of server-side stuff. I've been moving more and more of my compute over to Convex because it makes a lot of things a lot easier. When we get into the webhook section, you'll see why that's so damn useful. I'm using Autumn for the payments. They are a new company that is wrapping Stripe to just actually look and feel really good. They allow you to configure things like plans and features and customers as infrastructure as code rather than just dealing with the hellish Stripe APIs. It's a really cool company. I really like them. I found it to be really, really convenient for better context. I'm also using Clerk for authentication, and then I'm using Daytona for the sandboxing instance. And one of the reasons why I put almost all of the actual compute on Convex, because Convex is a database. It allows you to do queries and mutations, define your tables as just raw TypeScript. It's really great. You've probably heard of it already. But what's really nice, you can spin up an HTTP server within your Convex instance, and you can just run raw actions, which are just Node.js instances running in the cloud. So I was doing all of the management for the Daytona sandboxes within my Convex instance. And the reason for that is because webhooks become trivial in Convex. Since even in dev, Convex is running remotely, I have a remote URL for my Convex instance. It's really easy for me to spin up my Clerk webhook system on Convex because it's just a static endpoint that I can just hit every single time, even in dev and in prod. It just works really well. Did the same thing for the Daytona webhooks, and I need webhooks in this because you can see in here, like I have my instance up here where it's currently slept because the actual architecture of this is every single user gets their own dedicated sandbox, which has their better context config loaded into it. It has their repos cached and cloned onto it. And whenever you go in here and you wake the instance, that's going to wake my specific better context instance. And you can see I'm streaming down. It's currently starting the instance, it's booting it, and now it's running. And Daytona exposes webhooks for the actual sandbox lifecycle so that every single time the sandbox state is updated, like in this case, the sandbox state was updated to started. Instead of the old state was starting, now it's started. That webhook will fire off. It'll get sent over to my Convex instance over a webhook. Then the Convex table that is storing the UI for this, so like I have an instances table within Convex, it'll update my instance entry to be now running. That will instantly get updated in the UI because Convex has that real-time two-way sync where anytime you update something on the backend database, it will instantly update on the front end because they have the WebSocket connections and it's really well made. It's really, really sick. This whole mental model of webhooks becomes really, really good when you're using Convex. I'm very happy with it. Also had someone ask in chat, how am I doing payment webhooks? And by the way, I've started streaming and recording these videos live. Probably going to start doing that on like Tuesdays and Thursdays most week. Just take a look for that on Twitch and YouTube. Good time, you should come hang out. But for the actual payment webhooks, I'm not handling any of those because Autumn handles them for me. Whenever a customer is created or a checkout is completed or whatever, that customer will get updated within Autumn and the plans will get attached correctly. I'm not clicking into these because it'll dox my email and I don't want to do that. But if you go and play with Autumn, you'll see they handle all of that logic for you, so I don't have to think about it, which makes my life so much easier. And another good question here, do you even pay for Daytona because they give you like $200 in free credit? So far, no, I actually haven't had to. Their sandboxes are incredibly well priced. I actually have pretty big instances for every user. Every user gets 2 vCPUs, I think 5 or 6 gigs of RAM plus 10 gigs of storage. And since they only bill on active CPU time and I automatically spin down the sandbox after 2 minutes of inactivity and they're really quick to spin back up, haven't had to pay for anything. It's been great. I went with Autumn over Polar, again, just because Stripe is really good. It's the thing that I want to be using as the actual payment processor. They're the industry standard payment processor. It's just that the actual experience of working with Stripe directly really sucks. Theo made a really good video about that. I think fixing Stripe is what he ended up calling it. And there's a lot of nonsense you have to do in order to get Stripe to behave correctly. Autumn just abstracts all of that away from me and makes it feel like a modern part of my stack instead of some legacy obnoxious API I have to be constantly hitting and syncing over webhooks. It's great. I'm also, of course, using Tailwind CSS for the styling. Tailwind is Tailwind. It's what we all use for very good reason. But the last like kind of cool thing I wanted to talk about in here is actually TMCP. This is a project by Paulo. He's working on the actual Svelte team. He's a really, really good engineer. And he built this really nice library for making MCP servers that's a lot better than the actual official MCP library for TypeScript. It's really, really nice. They use this to make the Svelte MCP. And I ended up using it to make the BTCA MCP, because the cloud hosted version also has an MCP server, which I just shipped. I've kind of started to come around on MCP. I still have a couple questions about it, and there's going to be a video very soon of me doing a deep dive into how MCP actually works, when you should actually be using it, what the hell are skills, when should you be using those, how to use your agents correctly in 2026 effectively. But for what Better Context is, I think it makes a lot of sense to make an MCP server. This MCP server will feel very similar to something like Context 7. It'll fill a similar role there. It's just going to get you better search results because it's actually going to search the raw code base. The trade-off there being it's a lot slower. So Context 7 is going to be a lot more lossy because they're doing embeddings over the docs, I'm pretty sure, which is, again, very lossy. There's no loss on Better Context, but Better Context can take 20 seconds for a generation. Context 7 can take like 500 milliseconds for a generation. So pros and cons here. Okay, nice. And to show you how this actually works, I'm running this model locally on my computer because I just got a new Mac and I thought it would be fun to show you how this works. But if I do, use the Better Context MCP to see what resources are currently available. So the MCP has two tools. It has one for listing resources and it has one for actually asking questions to the resource. It's taking a minute to spin up here because it's running locally on LM Studio. So it has to boot this up. It's setting all this up. I think we're in here now. Give it a moment to chug. Okay, there we go. So you can see what it's doing now is it's going to use the Better Context list resources command, which is basically just a wrapper around an HTTP endpoint that would be returning a bunch of resources here that the model can call directly. It's really nice. So in this case, my instance currently has Svelte, Solid, Vite, Tailwind, all this stuff. The way this works in the web app is you just define your resources up here. I have this list of like curated ones. So if you just want to quick add any of these, like quick add the Solid.js docs, now it's added to my BTCA instance and I can add this and ask it questions, or you can manually add something from a Git repo up here. But for this one, what I want to do is let's ask it something about convex work pools. Use the Better Context MCP to research the convex work pools. Let me know why I should use convex work pools, and then also how do you set up convex work pools within your convex project. So now it's going to yep, there we go. So it's going to call the Better Context ask tool, which is an MCP. It's going to remotely hit my Better Context instance. You can see it's now starting it up. Now the instance is running. It's going to be streaming that down in the background. You can't see that as it's happening, but after about 20 seconds or so, it'll get its results and then spit out the correct answer there. Oh, nice. And you can even see here, like it got some information, but it needed to learn a little bit more about it. So it asks another question, hits the cloud instance here. It's really, really nice. And also you can see in the chat UI here, I should probably have done this earlier, but like if I do @runed, how do I store state within the URL using runed library? Cool. So we'll ask it this. The instance is now ready. It's asking it how to do this. And you can see what it's doing out of the hood. Couple tool calls, found everything it needs. Going to give me my nice up-to-date information here. Love this for research. And you can see in the MCP demo here, it is now accurately streaming everything down. This is the install command. This is the configure, create work pools, all of this stuff. It figured out how to actually use this. And to be clear, for this example, I very deliberately wanted to use GLM 4.7 Flash because what did I ask it to do in here? So I'm going to copy that. We're going to go into LM Studio. We go back to chat here. I'm going to hit new. What are convex work pools and how would I use them? I'm not really sure if I should add them to my project. What are they, and how, if I do want to add them, how do I set them up within an existing convex project? So when I ask this local GLM 4.7 Flash, what are convex work pools? I'm guessing that the answer here is going to be utter nonsense because again, it has no idea how to do this. These models are really smart and they can figure shit out really, really well. The problem is they are trained on data. And if that data has changed since their training, they're not going to know how to do something. So let's see. So it actually has some convex stuff in its training data. So this on a first glance, this looks passable, but it's saying here, define workers. Is this correct? We can reference the actual real implementation down in here. It's not. It's incorrect. So you can see the really nasty thing that can end up happening here with these models is the real way you do this, if you actually search the code base, is you make a new work pool here. And you can enqueue actions that way. The model, because it wasn't trained on this and didn't know anything about it, hallucinated this. This isn't real actual syntax that exists. This will not work. This will break your code base, but it's going to try really hard to do this. And this is what ends up happening to a lot of people is when they'll try and go vibe code something complex. They're just going to let the models go off and do it however they want to. And since these models don't know everything, they're going to hallucinate random stuff. And this is going to result in some hellish bugs that Better Context is very much designed to fix. Yeah, it goes down after 2 minutes of inactivity, but it's insanely fast to wake. Like if I hit wake, it takes like it's starting, done. So it's up in like 5 seconds. It takes no time to spin back up. This can actually be okay sometimes. I'm actually more okay with it searching node modules than I used to be. My biggest problem with searching node modules is that most of these projects are not designed to have agents search their output. When you do a build of some random project, it's just going to generate a bunch of like random TypeScript files, random JavaScript files that don't really mean all that much. There's no documentation in there. There's no semblance of how it actually works in user land. If they embed documentation within the node modules, that's dope. But I've actually heard of a couple companies starting to do this, which is really cool. They're making it so that if the agent starts looking in their node modules, they put some helper files in there that's like, hey man, I know you're probably looking for this, but here's how you actually search the node modules. And then the LLM will be like, oh, cool. And then it'll search it correctly. But most projects don't do that. And as a result, it really helps having a real search tool like Better Context or Context 7 or any other thing that will let your models search the real world instead of their own made up hallucinated reality. While I was yapping, the Opus instance put together its first plan of how we could implement the actual Raycast extension. The first thing it's doing here is it's giving me some options on the authentication strategy. The first one is we could use OAuth or we could use API key. I want to use API key. It's going to be way simpler. Then, since it had Better Context, it was researching how to do SSE streaming into Raycast. It realizes that this doesn't actually work. So what they can do is they can do like a pseudo streaming approach in here, which I'm totally fine with. That looks good to me. UI design is going to be very simple. Question, resources, submit. Yep, that looks good. Streaming response, blah, blah, blah. Yep, I like this. Dependencies, Raycast, Zod. Make sure we're using Zod 4. When you install dependencies, use bun to install them. Don't just manually write them to a package JSON. We'll need SSE parsing logic. That's fine. Authentication method. And for the questions, for number 1 on the authentication method, I want to use the API key. For thread management, we're not going to do any thread management within the Raycast extension. Every single question will be ephemeral. It's just a one-off thing to keep things super, super simple. For research fetching, we should fetch those on open. We don't need to cache them. It's super quick to do. Just fetch them on open. In Raycast, we can just show the loading indicator. We don't need to get this deep within the UI for number 4. Then for error handling, yep, subscription required. For the show upgrade prompt, just have it linked to the actual BTCA web app. Then for instance provisioning, if we can make the setting up message really easy, then yeah, we can do it, but lean towards keeping this as simple as possible. And that right there is what I really wanted to show off. There's been a lot of talk about how software engineering is dead. We don't have to write code anymore. All the engineers are going to get replaced by AIs. And hopefully that does a very good job of showing you that that is not the case at all. If you didn't know how to write code, if you weren't doing this for a living, you would not know how to correctly answer these questions and design this in a way that it can actually be implemented properly. You wouldn't know the difference between clerk OAuth versus API key. I know what both of these mean. I can make decisions about this. Thread managements, I have a good mental model of how the actual project works and how I want this to work. And as we just keep going down in here, there are more and more things that you need to know how to program in order to do. And to give you another example of this, because we're going to be creating the Raycast extension as a new app within apps, but Convex lives within the source directory of the web project, we can't share types in between these. We would have to like export Convex from web or something, or we would have to move it to another package, or we would have to hit it over HTTP actions, which that's what I'm going to do. I'm going to tell it that I wanted to create new special Raycast endpoints within the Convex HTTP server that will actually serve out the functionality for this. And again, that's an engineering detail that you need to understand your projects and know how to write code in order to do. Yes, I'm not writing the code, but yes, I am very heavily thinking about the code. Another thing for how we're going to do the data fetching and mutation for the Raycast extension, right now, all of the Convex stuff lives within apps/web. I want to leave Convex in there just for now to keep it simpler. I don't want to break Convex out into its own package. So as a result, we're not going to be able to directly import types into the Raycast instance and like directly do a use query or something like that. I'm fine with that for now because WebSockets don't even really work in there. Just have all of the Raycast data fetching and mutations happen over HTTP, and those HTTP endpoints should live within the Convex server. Make special new HTTP endpoints for Raycast, so we should have like /Raycast/resources. And then within /Raycast/resources, it should return the full list of resources that the user has access to. there should then be the /raycast/ask endpoint, which would be a post request that would then start the stream and send everything down. Both of these should be authenticated using the API key. If there's no API key, send the error. If they don't have any subscription available, send that error as well. You get the general picture. We need to handle everything that way. Then for the actual resource tagging, just have that be the @ syntax that we're using within the app/web project for the UI there as well. We can't do the like super dynamic highlighting of it and the drop down for like letting you pick resources and stuff like that. But for right now, just to get a working MVP, I'm okay with that trade-off of they just have to manually @ the thing without any real feedback. Lots and lots of feedback being sent back into the Opus instance to figure all this shit out. It's chugging along, figuring out what the flow of this is going to be. And then when I'm done with this, what I'm going to do is I'm going to print out all of this into a markdown file, because you can see up here, I'm already through like 65,000 tokens worth of context. So if I just started implementing this within this same exact session, there's going to be a lot of context rot in here because we already have so many tokens. We don't want that at all. I want a fresh instance. That's kind of the main principle of the Ralph loop, is you get a fresh session every single time you do a step. So let's go ahead and review this real quick. Resources, yep. File structure, yep. Form, text area, on submit, API key field, yep. Okay, 2 more things for the actual Raycast implementation. For one, hard code the URL for the convex instance. I'll give you that at the end here. And then there was one other thing I was thinking of. Fuck, what was it? Oh, and when you actually scaffold the Raycast instance, make sure you are using the real Raycast commands to create the Raycast project. You're not just hard doing it on your own. Use their built-in CLI to scaffold everything and make sure that it is a properly set up Raycast package. Use Bun, of course, as the package manager, and make sure to include all of this in the detailed plan you put together. Once you have all that figured out, write out a very detailed plan with some code examples, everything that is needed for me or an agent to actually implement this project into a Raycast extension.md file within the root of this project. There we go. So last thing we're doing in here, some final cleanups of how I want this to work. We're going to put that in an MD file. There we go. See, and you can see it's using BTCA in here, asking it, how do I use the Raycast CLI to make a new extension, figuring all this stuff out. And now the plan is put together. So it made the MD file, part 1, convex HTTP endpoints, get for this, post for this, yep. Extension setup, npx, create Raycast extension, convex URL. Actually, that's not the correct convex URL. Let me get it for them. Actually, sorry, that's not the correct convex URL. This is the correct convex URL. Okay, there we go. And this is another thing too, I've heard people say of like, when you're using voice to text, it's a little lossy. Like, yeah, it did, the voice to text thought that I said codex instead of convex, but it doesn't really matter. Like, it's still going to figure it out. Like, when I hit enter on this, it's going to know what I meant when I said this, and it'll update the document with the correct URL. It's really nice. Types.ts, odd schemas, API, HTTP client, yep, stream, ask, single command, ask, @resource, error handling, use promise. Yep, this all looks good to me. So you can see we had this long session here that went through about 78,000 tokens to get all this set up and working. I would not want to actually do the implementation within this same exact session because it would end up bloating the context to hell and it would result in much worse outputs. This is a place where a Ralph loop would make a lot of sense, because what the Ralph loop would do, it would take each of these parts. So I have this part 1 right here. I would have it basically say, okay, do part 1 in 1 generation. And then when you're done with part 1, make some status file that says you're done with part 1. Then the while loop would continue. It would spin up another open code instance that would have the context of, okay, I've already done part 1 because the markdown file says I've done part 1. Now I'm going to go ahead and do part 2. And you would have each of these parts be done by a separate agent. I'm kind of lazy right now and I don't really feel like setting it up. We'll do a dedicated Ralph video later. But yeah, for right now, we're just going to do that. That all looks good. Cool. I'm happy with this plan. We're going to do GTM-CAM plan put together. Cool. And then one last thing, use BTCA as much as you need to. You can see what resources you have in btca.config. Yep, there we go. All right. Nice. So now that we have all this put together, I'm going to spin up one last open code instance. I'm going to set this to be Opus. I'm going to do the implementation in Opus. I've played around with having like Composer do this or Sonnet do this or something like that. It can actually work pretty well, but in this case, I'm going to let Opus do it so that the demo works. MD, Read the Raycast extension MD file to see the actual plan for what you need to implement. Follow all the steps in there, get everything done. If you run into any major problems, stop and ask me, but it should be pretty smooth sailing. Use BTCA as much as you need to and get it implemented. There we go. And now the feature is going to get built. This is again why you have to read the outputs. I am not part of Anomaly Co. Whatever. We'll fix that later. It doesn't really matter. Okay, there we go. Raycast, bun dev, bam, continue. At Svelte, how do I use the state rune? Ask the question. All right, we're getting an error request failed. Let me check on the convex logs to see what ended up breaking. Okay. So I just tested it out and I'm getting this error within the convex logs. I think that you set up the HTTP endpoints to be like auth HTTP endpoints. They should not be running through the auth check. We should not be parsing or validating any JWTs in this. Purely, we should just be checking for the API key header, not any JWT stuff. Make sure that we are using separate logic for the Raycast stuff. That should live in a very separate place from the other API endpoints. The current API endpoints are fine. Those work correctly. We don't want to fuck with those. Just the Raycast ones need to be implemented differently. And once again, this is why you still need to know how to write code, because like instantly I can see this error and know, oh, okay, it's trying to parse the clerk JWT through one of the convex endpoints. I don't even have to read the code. I just know that's what it means. And I'm able to direct it to do the correct thing and make sure that everything stays separate and I don't end up introducing some hellish tech debt where we break authentication on existing endpoints. And then when I do the code review on this, we'll obviously be checking for that. This is all just stuff you have to do to actually write good code. All right, so it's gone through. So I think the HTTP actions should be better now. It's all restarted. Actually, let me make sure in here. Yep, everything reloaded. Let's go to ask question. Let's do at Svelte. How do I use the state rune? Enter. Thinking. So now it's going to be doing stuff. I honestly doubt that it's going to be able to directly stream everything down. Okay, so that error popped up and that was weird, but like, holy shit, it worked. Like we are now streaming down into Raycast. That's it. I didn't write a single line of code for this. And now we have a not full, like this needs a lot of polishing, this needs a lot of work, but this is a proof of concept of a Raycast extension put together in about probably 20 minutes of work at most. And this was like me yapping back and forth with chat the entire time. This is the point that I was trying to get across in my like software engineering is dead video that I did like a week ago. You still have to know how to write code, you still have to do all this stuff, but the things that we can do now, this would have taken me like a day at least, like a day or two of actual work and thinking and research to actually figure out before. Now I can just understand the high level concepts, let the LLMs search using something like Better Context to get the up-to-date info on how to really do this shit and do it. And here we are. We have a functional Raycast extension. That's it. This is why everyone is so hyped about this. It's not fake. It's very, very real. All right. Yep, exactly. And that's exactly it. It's like the extension is done. Now we just need to polish the hell out of the UX. We need to make the UI even better. And then, yeah. That's where we are. I'm not writing tons of lines of code. I'm just thinking about code. And to finish this off, everything for Better Context is fully open sourced. I'll have it linked down below if you want to take a look at it. You can see all the madness I'm working on in there. I wouldn't use all of this as gospel for how to write really good code. The passes to lock everything in and make it super, super robust with effect and all that stuff is coming in the future. I'm just trying to figure out exactly how I want this to work. But for an MVP first draft that I put together in about 2 weeks, I'm very, very proud of this. If you're interested in it, go give it a shot. I don't think I have anything else to talk about. Hopefully this has been entertaining. If you made it through this entire thing, thanks for watching. Make sure you like and subscribe, and I'll talk to you again soon.